Lesson 1.5, Point-Slope Form for Linear Equations. Point-slope form is a nice form to use when you're given certain types of information. The official form of point-slope form looks like this, where x1, y1 is a point given to you, and then they would also give you the slope of the line m. Now, if we have a nice little table here to kind of look at when and where we would use certain things, but if you were given the slope in one point, you'd plug these into the point-slope form and then rewrite the equation into slope-intercept form. Most of the time you have answers in slope-intercept form, so that's kind of where it would go, but it's nice to start by putting information into point-slope. If you're given 2 points, then find the slope using the slope formula, and then you'll be back to what you had before, the slope, and then just use one of your 2 points that you were given and put that into the slope, the point-slope form, and then find out the equation again from there, just like you had done in the previous example. Let's take a look at a couple examples. Write the point-slope form of the equation of a line through the given point with the given slope. So as we said before, it's y minus, it's y minus y1 equals m, which is slope, x minus x1. So here is x1 and here is y1. So I want to go y minus y1, which is a -3, equals the slope, -4/3, x minus whatever the x1 was, which is 3. Now this would be good if I didn't have this minus negative, so officially you should write it like this. And this is considered point-slope form. Alright, now below in example 2, you have an equation that's already put into point-slope form, and now they want you to put it into slope-intercept form. Well, the nice thing here is it's not much work. We would get rid of parentheses first of all because slope-intercept doesn't have any parentheses. And we have y minus 2 equals 5/2 x plus, well, let's see here, 5/2 times 3 is like that, 3 over 1. 5 times 3, so we go top times top, we get 15. Bottom times bottom, and we get 2. So 15 halves, and we can reduce that down to 7.5. That sounds pretty good. So I'll just write 7.5. We have one more thing left to do, and that's to solve for y. So add 2 to both sides. The 2 can't be combined with the 5/2 x because they are not like terms. But this sure does go together. And that would be considered, again, slope-intercept form. So if it's in point-slope, it's not a lot of work to get it changed to slope-intercept form. Here we want to write the slope-intercept form of the equation of the line through a given point with the given slope. Now, there's a nice hint here, and that is to first write the point-slope form, then convert it like we just did. So again, we have y minus y1 equals m, x minus x1. So let's try that. Again, they want it in slope-intercept form, so we're going to start with point-slope form because it's much easier to work with. We have x1 and y1 here. So y minus a -4 equals a -3/4 x minus x1, which is 4. So again, it's y plus 4 when you subtract a negative. We distribute, and we get -3/4 x. Negative times a negative is positive. So what is that? 3/4 times 4, 4 over 1. I took the negatives out because I already know my sign. 3 times 4 is 12. 4 times 1 is 4, and that reduces to 3. So that is considered point-slope form. Now we want to write, or I'll take that back, we're working our way here towards y equals, sorry about that. So we distributed, and now we do not have any parentheses, so one last step. I went backwards there. Subtract 4 from both sides, and that would give us an equation solved for y. Now, again, -4 does not go with the 3/4 x. So we have just 3 minus 4, which is -1. All right. Example 4, we have first write in point-slope form of the equation, b, then write in slope-intercept form. Now we have two coordinates given to us. So before it was pretty nice, we just plugged it into the equation. Well, we have two coordinates with no slope. So this is where we say use the slope formula, which is y2 minus y1 over x2 minus x1. Now if you've heard me before, I usually go y1 minus y2 and x1 minus x2. Now notice they are different, but they give you the same results. As long as your top and bottom are in the same order, you're fine. So I've not been convinced of any why we have to do one way or the other. As long as they're the same, then I'll take either way. So you just have to be careful about order. If you do order, the same top and bottom, you're fine. So let's go call this x1, y1, x2, y2. So I'll stick to their formula, the official formula. I'll do that. And that is y1 or y2 minus y1. So y2 is 1 minus y1, which is a -5. So it's y minus a negative. x2 minus x1. So we have 4 minus a -2, which is 1 plus 5 over 4 plus 2, which is 6 over 6, which is 1. That's our slope. So we now have y minus y1 equals m. Oops, sorry, I know that now. Y minus y1 equals 1 for m, which you don't really have to write. Now we just have to plug in a point. Now you have two to choose from, so pick one that looks easy to use. I want to choose the second one. So I would have y minus 1, because that's y1. Now notice it's y1, x1 in my point-slope form, but I could really choose either one of these. It makes no difference. I labeled one of these x1, y1, and one of them x2, y2, just because I need that for the slope formula. But it does make a difference which one we use. It's up to us. So I'm using this one. So I have 1, and I have x minus x1, which is 4. Okay, so we would distribute that, and again, like I mentioned before, distributing 1 doesn't change it at all. So we add 1 to both sides, can only go with the 4, so y equals x minus 3. And again, you can put a 1 there if you want to, but you don't have to. And this ends lesson 1-5.